started. The very first module of the AWS Azure, Microsoft Azure Cloud Computing, that is Introduction to the Cloud Computing. This is what I've got for you: a story to the cloud computing, and introduction of cloud computing, that is a book definition, and then cloud qualities or characteristics, and then we'll talk about cloud computing and the virtualization, integration of these two, and the cloud deployment models, right? That is your hybrid cloud, community, public, and private. And then we'll also talk about the cloud services category, or you say the delivery models, right? Infrastructure as a service, platform as a service, or maybe software as a service, and a couple of other things. And then we'll talk about cloud computing use cases, right? Where all it fits into, and the best use. I mean, in what all situations that cloud computing is being used, at least the Azure cloud is being used, right? That said, quickly get started. And you saw the learning path that we'll be covering the fundamentals, then the 533 certification. So those who have attended my demo class might have seen this particular slide, maybe next couple of slides, that is a story to the cloud computing. But yeah, please be with me. That is the consumption area, right? That is the application. What is an application, or the application program? The application or application program is designed to perform a specific function for a user, or for an application program. I mean, for a user directly or indirectly to another program, that basically to help the users. Okay, so that is an application. So as an example, we have got, like I said, the word processors, maybe the Office suite, MS Office suite, maybe the databases, browsers to help us browse the internet, or the development tools, maybe the Visual Studio, Web Matrix. There are many development tools, Eclipse, drawing and painting, image and video editing, and you've got communication tools like email, chatting, and there are many other tools. And these are the very few examples of the application. As you see today, there are n number of applications that they are internet based, that are the classic desktop based applications. But today the percentage is like more of a web based, less of a classic, but still there are n number of examples for the applications. So those are all the applications developed to meet a specific purpose, So this is a consumption area. But what do you think that you need to run the Office 365? What do you think that is needed to install the Gmail, which is a mailing solution? What do you think that is needed to host such a big social website called maybe Facebook or LinkedIn, all these web applications? How much will be the database, do you think? Right? So let's see that. You know one side of the coin, and of course you know the other side of the coin too. But the applications that we all consume, like I said, it can be the Facebook, LinkedIn, the Gmail, or any other web application today that we are using. That is a consumption area. But do you know the other side of the coin, the other side of the application, that what it needs to install, or what it needs to run an application, the enterprise class application? It needs infrastructure to get installed or to run the application area. Okay, so what do I mean by infrastructure? What does that includes? Well, that includes your server hardware, networking, storage, operating system. It can be Windows or Linux, and then you've got virtualization, and then of course the cloud computing. Okay, so the infrastructure includes the following components. You need a server to install an application, and then to connect to it you need the network connectivity. And then let's say if it is a database, to store the data, you need a storage. You need massive storage capacity. That's the storage. And then to handle, I mean, to talk to the hardware, to talk to networking, storage, and get your job done, you need an operating system, because we cannot directly talk to the hardware and get our job done, right? So we cannot understand the machine language, and machines cannot understand our language. That's where you need an operating system in between. And of course you've got virtualization, because of late you see every single company is actually leveraging the virtualization platform to take the benefit of cost effective solution, or to take the benefit of the reliable, or maybe the platform native high availability business continuity solutions, maybe the effective backup solutions. And then from an virtualization, it is further extended to the private cloud or the public cloud area where you can have the applications hosted. So that's the reason your infrastructure includes the following mandatory components. And then all infrastructure components are placed in a data center. Well, what is it? Let's say you are a database administrator, and then you have a server placed nearby your desk, and that is actually hosting a massive database that is contributing to maybe a billing application of your organization. And one of your friend have come near to your desk. He find it very interesting. They maybe he just uh, unplug a cable, maybe powered it off by pressing a button, and something he did resulting which the server went down. That caused the billing system to go down, which is causing the direct revenue impact of your organization, right? So to avoid such kind of unauthorized access and to protect your servers, you put the infrastructure components into a secure place, maybe into a secured room, and you configure the air filters, you configure certain temperature control, and then you have access control mechanism for that, maybe the biometric or the ID card access, something of that sort, and you call that as a data center. Okay, you call that as a data center. Now, where can the data center be, or where can infrastructure be hosted? The first place is on premises. On premises meaning it is in your office premises. Okay, you are one of those companies like TCS, Wipro, Infosys, Google, Microsoft, AWS, VMware, one of those companies who have the data centers, and the data center is in the same office environment where actually you have the office. It's on premises. The second place is on-premises managed data centers. So it's on-premises but being managed by somebody else. Well, Venkat, can you give me an example? Oh yeah, definitely. Let's say you are a car making company, maybe like say Maruti. Okay, so you have got manufacturing unit maybe in Gurgaon or maybe in another location in India, maybe one or two manufacturing locations in India. However, you have n number of sales points in different countries, n number of sales points in different countries, right? So for you to maintain the catalog, different products that you sell, and for you to maintain the items in stock, items that are in transit, items that are sold, the service warranty, right, the partnering that you do with different vendors. So all that information to have, and to have the staff details, offers, whatnot, all the details, to maintain them, you need an IT department. You need, obviously you need servers, and to have the internal communication, be it the mailing or the charting solution, you need IT. Okay, so in that situation, you being the master into the car manufacturing, certainly do not wanted to certainly do not wanted to or rather than do not wanted to, you do not have skill set in hiring a server admin, networking admin, storage, database, application developer, testing team, QA team, maybe the manager, IT manager, VP, CIO, CTO, right? You see no sense in hiring the entire IT vertical because you do not have the skill set. Rather, you wanted to outsource it. Okay, so then you call for the bids. Companies like the TCS, Wipro, Infosys, all these, whoever is into the services like CSC will bid for it, and while they are bidding, they will say, hey, I have maybe 10 years of experience. I mean, the employees that I've got, the resources that I've got have got 20 years of experience, they are certified XYZ stuff, and I can support you for 3 years or 5 years. This is the amount that I'm quoting for. Certainly all other vendors will do it, and Maruti will pick one of them. Let's say the project is given to Infosys. Okay, and then maybe after a while, let's say the 5 years contract it's given to the Infosys, and Infosys will handle the server hardware is actually the Maruti's owned property, and the support, the subscription with vendors, everything is Maruti's, but the services are handled by Infosys. Okay, so that's called the managed data centers. And then uh, the third place where you can have the data center is on cloud or in the cloud. Okay, well, that's where the big question is, what is the cloud? What is the cloud? We know a server, or we know the infrastructure. We know where this infrastructure can be. It can be in a data center, and we know a data center can be on premises within the office environment, or it can be on premises managed by the vendors. That is also fine. But what do you mean by cloud? Well, companies like Google, Microsoft, Amazon, or the other vendors, actually, they build the data center. They build the data center, including all infrastructure components that I said, including the operating system, including the application licenses, everything put together. They make a complete functional data center, and then they will let you access it through an internet connection. They will let you access it through an internet connection. That's called the cloud computing, meaning IT services are being delivered over the internet to the customers. That's called the cloud computing. And we are trying to understand the Amazon cloud, sorry, the Microsoft cloud, that's called Azure. Don't mind that you always find me confusing between Azure and AWS stuff, because I train on both the technologies. That's reason, these are the two words that I use very oftenly, right? Otherwise, please don't mind. So that's where we are trying to understand Microsoft cloud solution, that's called Azure. Okay, so the implementing Microsoft infrastructure solutions, that is 7533 certification, is more into delivering infrastructure as a service to the customers. Okay, so I'll explain you what is that infrastructure as a service or the other delivery models, but I believe you understand what the cloud computing is. That said, this is a conceptual knowledge. Let's see the book definition of a cloud computing. Okay, the book definition of cloud computing. But when you go for interviews, either of the definitions will do, right? You don't have to read the definition that you study in a book, but you can explain the concept that you have in your mind. That works. So definition for cloud computing is a standardized IT capability delivered via internet technologies in pay-per-use self-service way is called the cloud computing. Okay, so I'm reading it one more time. A standardized IT capability. IT capability, when I say, it can be a service, it can be a software, or it can be the infrastructure, it can be database, storage, right? The IT is like a big word. It has everything covered into it. Information technology is like everything in IT. So the entire information technology can be delivered via internet technologies in pay per you go or pay as you go in self-service model. That's called the cloud computing. Even to do a deep dive, cloud computing is a model for enabling convenient on-demand network access to a shared pool of configurable computing resources. Example, networking, server, storage, application, a database, or any other service that can be rapidly provisioned and released with minimal management effort or service provider intervention. Getting me? Cloud computing is a model for enabling convenient on demand. If you see the keywords that you can listen to here in this particular slide, it's very important. You see, pay as you go, self-service, on demand, right? Pay attention towards these words in the next slide. When we talk about the qualities of the cloud computing or the characteristics of the cloud computing, I will be elaborating more and more on it, so that you will get the conceptual knowledge about the cloud computing instead of the book definitions. Okay, so because if I have a server that is connected to the internet, and if I let you access it, can I call myself the cloud provider? Well, it's a big question. Can I? Now, with this knowledge, the knowledge that you have now, knowledge that is shared by me now, you will not be able to tell the right answer. um, can can I call the cloud provider or not? But yes, when I complete the next slide, you will get a general understanding on cloud computing, and you can definitely answer my question. Can I myself call the cloud provider when I have a single server connected to internet and I let you access it and work on it? Okay, so coming back, so cloud computing is a model for enabling convenient on-demand network access to a shared pool of configurable compute resources that can be rapidly provisioned and released with minimum management effort or service provider intervention. So if you are leveraging Azure cloud platform, you certainly don't have to write a mail or call Microsoft and ask them, hey, I need a server, can you please provision it for me? You don't have to ask for them, you can do it yourself. That's where we call it as self-service, right? If you need it midnight, 12 o'clock, you don't have to wait for anybody's permission, you can just wake up and do it yourself. That's called on demand. If it is a public holiday, you still can log in and then provision a server on your own. That's called on demand, right? So it really doesn't matter what time of the day, what day of a month, what month of a year, but it's all up to you when you wanted to provision a server. You just get onto it and provision a server, right? So this cloud model promotes availability and is composed of 5 essential characteristics, 5 mandatory qualities rather I say, and 3 service models, 4 deployment models. That's exactly the cloud computing. When you understand the 5 mandatory qualities of a cloud computing, 3 service models and 4 deployment service models and deployment models, then you got a fair understanding about the cloud computing, right? This is a second definition I can help you understand. The third one is maybe cloud computing is about IT capabilities that are rented instead of owned. These IT capabilities are delivered from a third-party service provider over a network. If you understand the sense of all these definitions, it's the same, that you are accessing the cloud, you are accessing the resources that are actually hosted in somebody else's data center, uh, and then you are consuming the services over the internet. Okay, the consumers of the cloud services uses the provider's hardware, software, which is located at the provider's facility. So the operating system, the applications, the hardware that we are using from Azure cloud is actually hosted in Azure data center, which is the provider's facilities. And the provider owns and maintains the hardware and the software. If a hard disk fails in Amazon data center, Amazon will handle it. You don't have to handle it, right? Though you configure, you create a virtual server and underneath hardware platform that you are using have some hardware issues, still still Azure will fix it. It's not you who has to take care of it. But if it is a traditional data center, then you have to go into the data center, log a support case with the vendor, get them replaced, and it's your piece of cake that has to be handled. But when you are engaging the cloud resources, the management efforts, the management overhead of the cloud infrastructure is with the provider. The consumers and the providers may be linked via the public internet or a proprietary connection, but the cloud computing doesn't mandate a specific technical implementation. The cloud computing will never tell you which internet connection should you go for, uh, what amount of bandwidth should you have in order to connect to a cloud computing. Should it be a public internet connection, or must you have a dedicated connection between your data center and the Azure data center? So it doesn't say anything about the product specific, but it says a technology specific. All right. So this is the high level understanding on the cloud computing to help you understand. And then let's see the 4 delivery models, or the 3 deployment models, or the 5 essential qualities that the cloud computing is talking about. A diagrammatical representation. Well, this is a high level diagram still. The common characteristics or the qualities, but the mandatory ones that you must have is all these 5. You must have the resource pooling, measured services, rapid elasticity, broad network access, and on-demand self-service. Okay, and then the service models. You've got software as a service, platform as a service, infrastructure as a service, and nowadays X as a service, meaning everything as a service today. Teaching as a service. You are engaging my teaching as a service on the internet. But of course, it's not on demand. We have a fixed schedule, but yes, right? Similarly, the deployment models. It can be deployed as a private cloud, as a community cloud, as a public cloud, or as a hybrid cloud, right? So those are the 4 deployment models. For the next couple of slides, I'll explain you about the 4 deployment models and 3 service delivery models, and the 5 essential or mandatory qualities of a cloud computing. All right, so let's move on. So firstly, the 5 qualities, that is your uh, the 5 mandatory qualities of a cloud computing. Okay, let's see the on-demand and self-service. Again, these are not the mandatory or the mandatory qualities that are enforced by me, but this is by a National Institute of Standards and Technology, NIST state. NIST states that cloud computing services must have the following mandatory qualities. Okay, so the services must be on demand and self-service, meaning, like I said earlier, no matter it is what time of the day, and no matter is that a public holiday or it's like a Saturday or Sunday, what day of a month or what time of a day, it really doesn't matter. It must be on demand. When you need it, you should be able to do it. I mean, you should be able to get it. And then self-service is, you really do not have to make a call to the provider. It can be Azure, it can be AWS, or it can be VMware, OpenStack, Oracle, for that matter, whoever the provider may be, but you really do not need their permission or their intervention in order to provision the services. Right? It is self-service. You yourself can go there and provision the services. Right? So that way, on-demand and self-service is one of the mandatory quality that any provider must have. The second quality is broad network access, meaning the cloud provider cannot say, hey, if you are in maybe West Indies, you cannot access the cloud. I mean, you cannot access my services. If you are in Arab countries, you cannot access my services. You only need to be either in US or in India, maybe Singapore. I can only allow you when you are in these three countries. But when you are rest of the world, I cannot allow you to connect to the cloud. I cannot allow you to connect to my services. That cannot be a definition, and you cannot be a public cloud provider. You must allow uh, everybody or anybody on the internet should be able to connect to you, and you must allow users from different devices, from mobiles, from maybe tabs, from the laptops, from the computers. So you should be able to allow the connection from any kind of device, right? So that's one of the mandatory quality, that is broad network access. And then the resource pooling. So if you ever work with VMware or VMware solutions, or maybe that you can have a data center here in India, I mean here in Hyderabad, you can have one more data center in Bangalore, one more in Pune, let's say, and the other is in Chennai, and you can build a virtual data center on top of all four physical data centers that you've got. Let's say, uh, let me bring, so you have a data center here in Hyderabad, one more data center in Bangalore, one more data center in Pune, and maybe one more in Delhi or somewhere else, right? So this may have some capacity, let's say 10%, 20% of the capacity, 30% of the capacity, 50% of capacity, right? Just to give an example. So you should be able to pool the resources from all these physical area and bridge a data center that basically gives you 100% resources. So that's called the resource pooling. So though geographically the data centers are scattered physically, but at a management console level, you should be able to pool the resources from all the physical data centers and show that as a single data center to the consumer, right? That's when you can build the scalable data centers. And then rapid elasticity. What do you think when you actually go to the Azure cloud? You can create an account for free, and they will give you $200 of credit, with which you will be able to launch any of the any of the Azure service for free of cost, right? And you can spend all $200, and you have 30 days of time, right? So what do you think with maybe the population globally, right? So if even 10% of them, maybe 5% of the global population started creating Azure account, free account, and they started launching the servers, what do you think the underlying infrastructure must be, right? It needs to be huge. You must have uh, many number of servers, huge number of data centers hosted, so then only it can support it can support the provisioning at that scale. And we are talking about the free tier, the users who are subscribed for free account. And then think about the corporates. There will be no no upfront notification to any cloud provider for that matter. If I wanted to create an account now as an organization and wanted to host some 100 servers, and maybe a couple of other companies in Hyderabad itself wanted to create Azure account and host maybe 100, 200, 500 servers in the Azure cloud, how do Microsoft get to know about our requirement upfront so that they can scale the underlying physical hardware to support such kind of needs? There is no idea, right? They certainly cannot guess it, but still they cannot enforce us saying, hey, you can only create 2 servers per day or maybe 1 server a day. They cannot enforce us, right? There must be sufficient resources available all the time to meet the customer needs. That's where the rapid elasticity comes in. Even maybe today I provision a server with 1 CPU, 1 GB RAM, and tomorrow if I wanted to scale it all the way to 128 CPUs and 2 terabytes RAM, I should be able to do it, right? So they should support the scalability that's come with the rapid elasticity as a feature of the cloud provided. And finally, the measured services, right? So within the organization, maybe let's say before we go there, let's say Azure cloud is being consumed by many organizations globally. Okay, let's say I'm a company A and you're company B, and I went there and provisioned some 10 Windows machines, 5 Linux machines, 2 databases, and maybe a couple of other services, and you went there, you just launched only 1 Windows machine. How do Microsoft bill you for only 1 server, and how do Microsoft bill me for 10 Windows, 5 Linux, and couple of database servers and the other services? How do they measure it? Or let's say um, uh, I've launched 2 servers. One is actually up and running for 15 days in a month, and the other is actually up and running for 30 days. How do they measure the usage to bill me 1 server for 15 days only, the other server is for 30 days? That is possible only when they do the chargeback mechanism. That's only possible when they do the measurement of the service usage, right? So there are tools available. The tools will measure the usage of or the service consumption, how many hours that you have used an EC2 instance, how many hours a database is being used, and even within the company. Let's say you are a company, you've got 10 departments, and each department need IT services. You said, hey, I'll give you separate subscriptions for 10 departments. Whenever you provision a service, you please use this subscription ID. That way the internal department can also be the cost centers. So even to track, for you to track your internal department consumption and to identify why so and so department is using so much of IT services and why the others are not, or maybe to do the internal assessment, right? So measurement of the services is very much important. So these are the 5 mandatory qualities that any cloud provider must have. Now if I say, hey, I have a server at my home and I can let you access it over the internet, and can I call myself as a cloud provider? Well, you will, without thinking twice, you will say, no, Venkat, you cannot be a cloud provider, because it's not on-demand self-service. When I need the server to be up and running, I need to call you, right? So it's not on demand, it's not self-service. And broad network access, maybe you may have restricted only my IP address, maybe only a particular MAC address to access your network and to access the server. Maybe a particular team your ID, or maybe a particular team your Gmail account which is integrated with that, but not the entire world, right? And you just have one server, it cannot be a kind of resource pooling. And if I have to scale to 2 servers, and then it's a kind of big exercise for me. I have to spend 1 more lakh, buy a new server, and then I have to use it. It's like a big exercise. It cannot be rapidly elastable, right? Rapidly scalable. And then measurement, I do not have a software that can measure the usage. I can never know how many hours a day that you have used my server so that I can ask you to pay back. So these are the mandatory qualities of a cloud computing. And then to move on, like I said, the integration of virtualization with the cloud computing. Well, you know that this is how the virtualization layer looks like. You've got the base physical layer, wherein you've got the memory module, hard disk, the network interface card, the CPU. 4 critical hardware resources. and top of these four you have abstraction layer, maybe the hyper visor layer, maybe the virtualization layer, right? So this is a specially built operating system that will enable you to create virtual instances of the operating system on top of it. Okay, so on top of this you have one more software that is sitting and that is allowing the cloud users, I mean that is allowing the users to access the services over the cloud, and you are integrating one more software that actually measures the service, that you are integrating one more software that actually gives you the network virtualization capability. So that way on top of the virtualization layer you will be adding few more services, maybe the few more components to deliver these virtual instances over the internet to the customers. So the Azure cloud must be using the Hyper-V as the virtualization layer. So Amazon cloud is using, so far it is using Citrix Zen servers, but then recently they have partnering with the VMware, so they must be using VMware ESXi in the next future, coming future. But yes, OpenStack must be using KVM, the Linux hypervisor. Oracle is using OVM as a virtualization layer. So in any cloud that you see, the virtualization is a mandatory layer, right? There is no cloud platform that built without the virtualization. So non-virtualized computers have one set of hardware. You have the hardware abstraction as well, meaning today the server must be running here in Azure cloud, and tomorrow this can be migrated onto AWS cloud, because these are just the virtual instances. The servers are abstracted from the underlying physical hardware. It must be a Dell server here it may be a HP server in AWS. So it really doesn't matter which hardware they were running, which hardware they will be running, but it only matters that they are virtual machines. They are completely abstracted from the underlying physical hardware. Okay, and then as I talk about, I mean, as you understand the cloud computing definition, and let's see the cloud computing deployment models. Okay, so the cloud computing deployment models, when it comes, there are four popular deployment models, that is the private cloud, the community cloud, public, and hybrid cloud, right? Let's understand what are these and how can you categorize them: private, community, public, and hybrid, right? It is all about one thin layer between all these is the network access. Okay, the network access. If you say, hey, I built the data center, right? On top of the data center I have the virtualization layer. See, when I say data center, it's like the infrastructure. Okay, that is server, networking, storage, all that stuff. On top of that you've got the virtualization. On top of that you've got maybe the chargeback mechanism, which is like the measurement of the service that I said, right? And on top of that, the self-service I've got, meaning it is integrated with the ticketing tool that you have. When a user needs a server, he just submit a ticket that goes through the approval chain, and the server automatically get provisions. Self-service portal that you have built and integrated with data center, and you only allow people from your organization to access your servers, to access your cloud platform. Okay, that's when it is called the private cloud. So you've got all other elements like elasticity, the self-service, on-demand, all other five mandatory qualities of a cloud computing, but it's not the broad internet access, but this is the access to the cloud computing is limited to employees of your organization. That's called the private cloud. Okay, and then to talk about the community cloud, let's say the healthcare organization, maybe two big hospital companies, maybe Apollo or maybe the NIMS, KIMS, or some other hospital company are trying to find a solution for HIV or maybe any other disease that do not have a solution as of today. Okay, I mean that do not have cure as of today. So as these two companies are working together to bring a solution, to bring a fix for it, what you can have is these two companies, I mean the big hospital companies need shared resources. Okay, so that a big piece of work can be split half of. So the company one will take care of the the first half, and the company two will take care of the second half, right? That way The second company, you will allow the second company also to access the same cloud platform, and you can also have the third company joining them. So it's the community is working to bring something useful. It's not necessarily the hospital company all the time. It can be the educational institutions, it can be general IT, it can be anything. When a couple of organizations form as a community and they have the cloud computing, but the access is only limited to those set of companies, that's when the cloud computing, that's when it is called the the community cloud computing. All right. And then when you enable the same data center, the same entire cloud platform, and you allow everybody on the internet to connect to it and to consume the services, that's called the public cloud. Right? When everybody on the internet can connect to it, that's called the public cloud. And when it comes to the hybrid cloud, you as a company, as an organization, let's say you have got the private cloud and you've got the public cloud as well, right? You're using multi-cloud environment. That's nothing but the hybrid cloud. You've got both private and public, so that you can move the workloads from private cloud to the public cloud and public cloud to the private, vice versa. You can do it. So when you're using multiple cloud solutions, that's when you're called as hybrid cloud solution, right? Hope you understand different deployment models, that is private, community, public, and hybrid. It is all about the accessibility of the resources. If you limit the access to employees of your organization, it's called private. If you limit it to a few companies, it's called the community. And you let everybody on the internet connect to your cloud platform, it's called the public. All right. And to move on, the delivery models. Yeah. So Sham, I understand your question. The hybrid cloud. Well, when you have any combination of the cloud platforms, let's say you have the private cloud and you are also using the public cloud. You already have the private cloud built for your company, and for some reason you've also engaged the public cloud solution. For example, let's say you are handling a project whose life cycle is for 4 years. 4 years. So to build this, to support this project, you brought everything that is needed to build a private cloud environment. It's running fine. And all of a sudden you've got one more project, but whose life cycle is just 6 months. So you thought to support a 6 months of project, you certainly do not have to to build in a data center again. Rather, you can engage the public cloud environment, right? So you went to Azure, you said you deployed few servers and you started supporting this 6 months project. And after completion of 6 months, while you are using both public cloud and private cloud, that's called the hybrid cloud environment. Okay. And maybe after completion of this 6 months, of 100 servers that you engaged here, you may need maybe 4 to 5 servers as a backup, or you want those services to be up and running. You just can move them back to the private cloud. Those set of servers, the identified servers, can be moved back. Okay. And if you wanted to move servers from private cloud to the public, that is also possible, right? So when you have multiple cloud platforms engaged, that's called the hybrid cloud environment. Okay. See, the difference between virtualization and the cloud computing is the 5 mandatory qualities that I said: the self-service, on-demand, broad network access, the rapid elasticity. Those are the 5 differences between the virtualization and the cloud computing. All right. Now, uh, when it comes to the delivery, right? How are you delivering the cloud resources? Let's say you understand cloud computing is nothing but delivering IT services to the customers. Well, what is that IT services? It's a big word again, right? So when you break that IT, the big word, into the small pieces, that's where you can categorize them into the software as a service, or platform as a service, infrastructure as a service, database as a service, storage as a service. So the big data as a service. So there are many services today in the portfolio of the providers, especially when it comes to Azure cloud portfolio. They have got close to 100 services that are those services are falling into different categories like you see on the screen: the software, application, platform. infrastructure, data center, sorry, database, and many other things. But the widely known or most popular delivery models are the software or application as a service, a platform as a service, or infrastructure as a service. Okay, so let me explain you what components fall into all these categories. If it is a traditional data center, these are the components that you can find. You have the networking stuff, the storage, the servers, virtualization, operating system, middleware, runtime, data, and application. It all these components have to be installed, configured, managed by you, and the lifecycle activities of all these softwares, I mean the components are actually handled by you, meaning your company. Okay, but when it comes to the infrastructure as a service delivery model, the provider will handle the networking, storage, servers, and the virtualization, and they will give you to deploy the virtual machines of your choice, I mean the operating system of your choice. You can create a machine of Windows operating system, you can create a machine of the Linux operating system. It's completely your choice. And then the middleware is your choice, runtime is your choice, data, application. So this is called the infrastructure as a service, in which you you will have control over the entire infrastructure. Okay, so this is the area that we are going to study for rest of the course that we are doing, part of the 533 certification, infrastructure as a service delivery model. And then when it comes to the platform as a service delivery model, it's the platform given to you, that is just your application code and your data, that's all. The underneath to that, like your runtime, middleware, OS, virtualization, it's all handled by the provider itself, right? When it comes to AWS, you've got something like web apps or websites or cloud services. When it comes to Azure, sorry, I'm so sorry guys, when it comes to AWS, you've got Elastic Beanstalk. When it comes to Azure Cloud Platform, you've got web apps, websites, or cloud services. When it comes to infrastructure solutions, for servers, you've got virtual machines. Okay, for Azure infrastructure as a service, I'm talking about, you've got virtual machine. For networking, you've got VNet or virtual networks. For storage, you've got blobs, tables, you've got a couple of other storage offers, storage options, right? So in Azure Cloud, you will be able to deploy a virtual server of your choice, build the networking of your choice, storage again is of your choice, applications is of your choice. So the entire infrastructure that is needed to build a data center is given to you in the cloud, so that you can build your own virtual data center in the cloud platform. But when it comes to the platform as a service, you just can upload the code so that it can provision the underlying infrastructure. Whatever is needed to run your application is provisioned automatically and handled by the provider himself. And the software as a service, well, you do not have to handle anything. The YouTube, I said, what do you do with that? You just can watch it. You cannot develop it, or nor you can do something with that, right? So in software as a service delivery model, there are no job opportunities. In platform as a service delivery model, it's only for the developers. But the infrastructure as a service delivery model is where you've got more number of job opportunities today. And of course, forever it will be the only area where you see a lot of opportunities. And on premises, it is as good as your data center. I mean, I don't talk about it. We are talking about the cloud, right? So these are the three widely used delivery models, the cloud delivery models, right? And then, so this is an example on how a pizza delivery looks like. When you engage, when you do it a pizza at your home, you have to handle everything on your own. But when you take it as an infrastructure as a service, like vendor will do the topping, cheese, tomato sauce, and pizza dough, and then you just have to take care of. You just put the base, the bread into the oven, cook it, and then you just serve it, right? Or when you take the pizza delivery, you just arrange a table and the drinks at your home and you eat it. But when you go to the restaurant, it's all handled by them, right? So this is of the software as a service or a platform as a service, and your infrastructure as a service can be compared, um, with the pizza delivery. And when it comes to the cloud computing use cases, well, in good old days, maybe early 2011, 2010. Actually, 2010 is a year when Azure cloud computing was actually announced. In those days, it was limited to the test and development, maybe at the disaster recovery environments. But of late, today, if you see, all mission starting from a sample websites, maybe the WordPress themes, small blogs, to mission critical applications, or maybe the large big data analytics, the online data streaming applications, right? Whatnot, everything from a small project to a complex, from a simple web application to a large data processing applications are actually hosted and being used into the cloud platform, right? So you can engage the cloud services in any form, that's software as a service, platform as a service, database as a service, infrastructure as a service, maybe storage as a service, disaster recovery as a service, backup as a service, so just big data or analytics as a service. So it fits into all your needs, right? So there is no specific use case, but it fits into all your needs of your IT. Right, this is what we have covered so far, a story to the cloud computing to help you understand what is an application, the consumption side of it, to the other side, that is what is needed to run an application. From there, infrastructure components, and infrastructure components are placed into the data center, and data center can be on premises or on premises managed data centers, or it can be in the cloud. So when it comes to the cloud, you understand that the data center is built, managed by the providers, and you connect to the data centers over the internet and you consume the services. And you understand that there are 5 mandatory qualities, 3 delivery models, and 4 deployment models of the cloud computing, and we have seen that so far. And this is the general understanding of the cloud computing. So if you have any questions, feel free to ask me now. This is it for today.